Hello, hello, hello. Hello. Hello, am I audible? Hello, 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 Navya, Ananya, and Kirtana. So, hello, guys. Hello, am I audible? Yes, I think I am. Yes. Good morning, Ada. Good morning. Seriously, good morning. So, guys, today we are going to discuss about coordination compounds. Okay, I hope it's clear. So, coordination compound. So, it's a very important chapter. So, you can confirm almost 2 question, okay, from this chapter, 1 to 2 question, okay. And it is a very easy chapter. So, from 2026 NEET we can see question from isomerismல இருந்து question வந்திருக்கு. Okay, isomerism இல்லனா IUPAC nomenclature இருந்து தான் question வரதுக்கு chances இருக்கு. Okay, isomerism இல்லனா IUPAC namingல இருந்து question வரலாம். So guys, உங்களோட preparation எல்லாம் சூப்பர் டியூப்பரா போகுதா? ஜெஹி, Hafila, Ananya, Navya, Jaishankar. So tell me, உங்களோட preparation எப்படி போகுதுடா? So tell me, guys. I'm new to class. Okay, yes. Hafila. Come on. Good evening, ma'am. Yes, Kirtana. So tell me, preparation super duper போகுதா இல்லனா மேம் கொஞ்சம் லாக் ஆகுது இல்லனா இந்த மாதிரி ப்ராப்ளம்ஸ் ஃபேஸ் பண்ணுது? அப்படி ஏதாச்சும் இருக்கா? So tell me. Hi. So tell me. Hi, Divya. Oh, Divya, this is your account. Okay. Divya. Yes. Hafila. Nitish. Yes, Nitish. Hello. So tell me, guys, how is your ma'am? Start early, ma'am. Rain will come. Can't. Okay. Raining irka. Okay, Kirtana. So, Kirtana, where are you from? Where are you from? Lakshmi. Okay, ma'am. Okay. So, Re-NEET oda energy. Okay, ungaloda Re-NEET ku energy திருப்பி கிடைச்சிருக்கா? So, இல்லனா okay, ma'am. இல்ல, அவ்வளோ energy இல்ல. Push பண்றதுக்கு. Again, tense இருக்கு. Ma'am, start early. Okay. So, we can start anyway. Okay. Yes. Durai is actually, I think, Durga. Yes, Durga, good evening. So, we can start the chapter. So, where is the slide? So, this is actually coordination compound. Okay, here, இதுதான் coordination compound ஓட ஒரு structure. Hello, Jayashree. Hi, Jayashree. இதுதான் coordination compound ஓட ஒரு structure. So, உங்களுக்கு ஒரு square bracketல ஒரு molecule பார்க்க முடியும். Okay, square bracketல ஒரு molecule, like ஒரு molecule ஓட ion. Okay, so இது waterல dissolve பண்ணா you will get plus and minus ion. So, in the square bracket complete ionize ஆகும். Okay, இல்லாம ion இல்லனா cyanide separate ஆகாது. So, complete you can see in the complete ion. Okay, this complete part will form one ion. Okay, maybe cation or anion. Okay, இல்லாம இதுல இருந்து again என்ன divide ஆகாது. Okay, இதுல இருந்து again divide ஆகி iron ஓட ion form ஆகும் இல்லனா CN ஓட ion form ஆகும். அப்படி இல்ல. So, this is actually one part. When you consider coordination compound, actually other two parts. One cation is there and another anion is there. Okay, one cation is there, another part is anion. Okay, so here you can see. So, cation தான் first எழுதும். Okay, so first maybe square part என்ன positive இருக்கலாம் இல்லனா negative இருக்கலாம். என்ன positive maybe square part இல்லனா counter ion. Okay, outer part தான் என்னடா counter ion னு சொல்லும். Okay, so உங்களோட square bracket க்கு வெளிய இருக்கிற part தான் that is actually counter ion, and this cyanide is actually coordinate pair. Okay, this cyanide is actually ligand. Okay, cyanide is CN is actually ligand. Okay, so listen carefully. This square bracket in the molecule or in the iron. Okay, iron is actually so square bracket in the part is stuck, ma'am. Let me check. No. No da. Illa. Sucking, my voice is breaking. Seriously? Just a second. Hello. Hello. Just a second, I will again. Hello. Still buffering? I think now it's. Hello. Now clear, Ada? Voice breaking, ma'am. Voice not clear, ma'am. Hello. Then I want to call technical team. Network problem. Hello. Same issue for everyone. Yeah, I can also see here. Just a second. I will call. Hello. Voice is not clear. Buffering, please. Okay. Just a second, Ada. Just a second. Not clear. It's buffering actually. Okay. Yeah.
Hello. Sound is not there. Other sound is there.
Yeah. I think. Hello guys. இப்போ கேக்குதா? Hello. Hello. Hello.
Keep it in pocket.
Hello. No voice.
No voice. Okay. Wait.
Just a second. So we will check. No voice. Video is loading.
Video is loading.
Yeah, everyone is saying
It
that
got stuck.
video is loading. It's loading, buffering. That is it. This is not work. It will not work.
Then how it was working?
Sometimes it will work. We will try. Yeah, it will take time.
But it's okay. It was
Then that. Ada. Video is loading. Ada. Now we are perfect. Something is there. Here I can also see. Oh, it's stuck. It's stuck. Still buffering. Nitesh, yeah.
and the whole drama happened.
Yeah. Oh.
Recently, that news also came, na, that JEE advanced paper got leaked. You don't know?
No.
Yeah, seriously.
Advance also. How?
But if that is not, that was the false.
For you. That's actually
And many people have made video. Even Vedanta also made. Then they private the video immediately. Please. But this is not connected yet. Hello. It was. Okay,
Hello.
is it fine now, guys?
Hello guys, am I audible now? Hello. Yeah, for me. No, loading.
Still loading?
Yeah. Yeah, for me. No, I think it's clear now.
Fine now.
It's fine. Yeah. No sound, ma'am.
Now it's okay.
Now it's okay. Yeah.
It's okay.
Yeah. No dustbins.
Oh, you carry on.
Okay, thank you. Thank you so much from our student side also. Okay, da, settle. Ada, settle. Okay. Audible, it's loading. Ada, no, it's not loading. It's fine. Hello, hello, hello.
It's fine.
Perfect. Audible. Yes. So guys, yeah. So here you can see. So when you consider a coordination compound, so a coordination compound consider பண்ணும்போது you can see two parts. Okay, you can see two part. One is cation and another part is anion. Okay, listen carefully. No, ma'am. Audible. Okay, clear, ma'am. Audible. Thank you. Okay. Audible but loading. I think it's perfect, Tada. I think it's perfect. Let me check again.
See, two parts. Okay, you
Yeah.
can
Yeah.
see two part. One is cat.
I think perfect. So everyone quickly smash the like button. Yeah, set it. Yes, set it. So yes, you can see two parts. Okay, two parts. So one is cation and another part is anion. Okay, for first part எப்பவுமே okay, so அந்த cation part எது அந்த anion part எது அதுதான் doubt. So you can see இந்த ஸ்கொயர்ல இருக்குல்ல, so இங்க பார்த்தா தெரியும் உங்களுக்கு ஒரு ஸ்கொயர் இருக்கு. So and first one is okay complement accepted. Okay, so உங்களுக்கு பார்த்தா தெரியும் ஒரு ஸ்கொயர் பார்ட்டும் இருக்கு and என்ன ஸ்கொயரோட வெளியில ஒரு பார்ட்டும் இருக்கு. Okay, so that square part is actually called what is that? That is actually coordination sphere. Okay, square part is actually square bracket part. Okay, that is actually coordination sphere and the outer part is called counter ion. Okay, the outer part is actually counter ion. Okay, so இதுல மேம் cation யாரு anion யாரு? Okay, maybe counter part cation ஆகலாம் இல்லனா coordination sphere cation ஆகலாம். Okay, so அது vice versa வரலாம். Okay, so first நாம என்ன எழுதணும்? First எழுதுறது தான் என்ன cation. Okay, first we will write cation. Okay, first we will write that is cation and here you can see square part. Okay, square bracket part, that is actually coordination sphere. So here the square bracket part or coordination sphere is actually anion. Okay, so this is anion and this is cation part. I hope it's clear. So anion, ma'am, this total charge is actually negative. Okay, the total charge of that coordination sphere is actually negative. Loading. It is still loading. Seriously, ma'am, buffering, loading, perfect. No, it's not loading. Just a second, then I will call him again. And the videos also. Hello, only 6. Hello. Hello, hello, hello. Hello guys, am I audible? Hello. Don't worry, ma'am. Appadi, I yes. It's still there.
Still it's there.
It's still there.
But
Two.
we just recorded because
Huh. That's the reason I'm saying no one is there. Then we can.
now check once.
Hello, hello. Guys, am I audible? Hello, hello. Jai Shankar, Sadhana. Is it perfect?
No sound at all.
No sound.
Yeah, we'll end it. Say something.
Hello. Hello guys, now it's perfect. I think.
People are saying now it's perfect, then why is it not here?
No idea.
It's full.
Huh.
People are saying now it's perfect, then why?
Ah, okay.
But why it was not coming that time?
No idea. No idea.
People are saying now it's perfect, then why?
Ah, okay.
I'll learn to do it. Why it was not coming that time?
No idea. No idea. I think it's perfect.
It's fine, it's
Yeah,
fine.
it's perfect now. Yeah.
Guys, just confirm once if it is fine.
Guys, audible. Yes. Perfect, ma'am. Yeah. Chill.
Your phone has it.
No.
Tell your ma'am to change the phone. When did you buy that?
3 years back.
Or change it.
Oh, I'm not that much rich. Mithun.
Okay, is it fine, guys?
I think it's fine, Alada. Tell me, da.
Yeah, please tell us.
Please, please, tell me. We all are waiting for you, okay? We all are waiting for your reply. No reply.
What is this? Students
Yep,
are not
yes.
responding.
Ashu. Guys.
You have to unlock it.
Ashu. It's fine, it's fine. Yes, it's fine. Yes. Fine, 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 fine. Perfect, perfect. I think perfect. It's fine, it's fine.
Yeah.
Okay, okay.
bye-bye.
Thank you. Bye, bye. Hello, hello, guys. Hello, guys. Huh. Hello, guys. Hello, guys. No. It's fine, Aleda. So we can start again. No, it's not fine. Fine. Perfect. Yes, fine. Okay, Navya. So we can start. So when you consider coordination compound contain two parts. Okay, two parts means I will use. Okay, so it should contain a complex compound. Okay, this is complex compound part. Okay, square bracket part. Okay, fine, ma'am. Okay. So that square bracket part is actually called, here you can see coordination sphere. Okay, so maybe coordinate compound, like you can see two square bracket part. Okay, two square bracket part you can see. So one is positive charge, another one is negative charge. Okay, so you can see that two coordination spheres. Okay, maybe you can see two coordination sphere. Okay, you can see two coordination sphere, that is, or at least, okay, it should contain at least one coordination sphere. Okay, it should contain at least one coordination sphere, then only we can say that yes, it is coordinate compound. Okay, it's a coordination compound or coordinate compound. Okay, I hope it's clear. So guys, quickly smash the like button. So the first part, okay, so I just mentioned that for all the time the first part is actually cation. Okay, so it is cation, and the second part is actually anion. Okay, first part is cation and second part is anion. Okay, so, and here this is a central metal atom, okay, this is a central. So we know that a square bracket, so square bracket contain one central first element, okay, the square bracket first element is actually central metal atom, okay, central metal atom. And hello Hema, how are you da? How are you da? So that is central metal atom, and this part, okay, after central metal atom you can see another part, that is actually ligands, okay, that is actually ligand. So here ligand is giving electron to central metal atom, okay, here ligand is giving electron to central metal atom, okay. So this is actually, here you can see, here 6 ligand is there, okay, here we are using cyanide, okay, cyanide is there. So CN means you can see 6 ligand is there, okay, how many ligands are there? 6 ligands are there, okay, 6 ligands are there, and it is coordination number. This is actually number of ligands is actually coordination number, okay, number of ligands is actually coordination number. I hope it's clear. So that this is actually counterpart means, so you can see square bracket la illama வெளியே இருக்கிற அந்த atom இல்லனா அந்த part தான் counter ion part, okay, counter ion part, and square bracket la இருக்கிறது that is actually coordination sphere. So counter ion, if you are writing a molecule means first you should write cation, then you should write anion, okay. So here you can see central metal atom is actually electron acceptor, okay, central metal is, yeah ma'am, good, all your blessing, yes, and yes Sadhana, feeling better now, okay da. So yes, take your health, okay, take care of your health, okay, that is very important, okay, take care of your health, okay. Yeah, so central metal atom is actually, here it is iron, okay, iron is the central metal atom, and central metal atom is actually electron acceptor, okay, central metal atom is actually electron acceptor, okay, this is actually electron acceptor. And you can see here ligand, okay, I just mentioned that CN is a ligand, okay. So we know that central metal atom is an electron acceptor, then ligand means electron donor, okay, this ligand will give electron to that central metal atom, okay. So next is coordination number. What is actually coordination number? The coordination number of metal ion in the complex can be defined as the number of ligands. Already I mentioned here, number of ligand is actually coordination number, okay, number of ligand donor atom to which the metal is directly bonded. So metal enna directly inga 6 cyanide mala bond la irukku. So and the 6 cyanide number of ligand is actually, now it is 6, okay. I hope it's clear. I hope it's clear. Then we are moving to, this is actually coordination compound, okay, coordinate compound we can say. So when you consider, first theory is actually Werner's theory, okay. So when you consider Werner's theory, it's mainly focused on valency, okay. Werner's theory is mainly focused on valency. When you consider valency, there is 2 type of valencies, okay, there is 2 type of valencies. So metal possess 2 type of linkages, okay. Here when you consider metal contain 2 type of valencies, okay, metal possess 2 type of linkage or 2 type of valencies. So first one is primary valency, another one is secondary valency, okay, one is primary valency, another one is secondary valency. So what is secondary valency means? So secondary valency is ionizable, okay, it is completely ionizable. So these are the satisfied by neutral molecules or anions. So I will tell you, when you consider NaCl, so if NaCl if NaCl mixed with water, you will get Na plus and Cl minus. Okay, you will get Na plus and Cl minus. Okay da, so NaCl in a water la dissolve panna, you will get Na plus and Cl minus. So guys, you know that it is completely ionizable. Okay, it is completely ionizable. So this type of molecule, this is actually secondary valency. Okay, this is actually secondary, not secondary. Okay, this is actually primary valency. It's completely ionizable, that is primary valency. So when you consider secondary valency, okay, when you consider secondary valency, so guys, it is a coordinate compound. Okay, K4, here in coordination sphere you can see FeCN6. Okay, FeCN6. So இது waterல dissolve பண்ணா நமக்கு என்ன கிடைக்கும்டா, இது waterல dissolve பண்ணா you will get K plus. Okay, 4 times K plus and FeCN 6 times 4 minus. Okay, so again in the complete inga irundhu, okay, inga irundhu ions, inga iron irukku, cyanide irukku, again adu enna, adu again ionize agadu. Okay, again ionize agadu. So inga இந்த ஸ்பியர்ல இருக்கிற அந்த மாலிக்யூல்ஸ் இருக்குல்ல, so அந்த ஸ்பியர்ல இருக்கிற compound இருக்குல்ல, அதுக்கு again என்ன ionization நடக்காது. Okay, so secondary valency is equal to the coordination number. Okay, it is equal to the coordination number and it's fixed for metals. Okay, it is actually fixed for metals. Okay, I hope it's clear. So when you consider NaCl complete Na plus Cl minus amaru. When you consider coordinate compound, okay, when you consider coordinate compound, so adoda counterpart and coordination sphere ions amaru. Okay, counterpart coordination sphere ions amaru. I hope it's clear. So here you can see, so we know that two type of valencies are there. This is actually Werner's theory. Okay, so primary valency is there, it is ionizable. So when you consider secondary valency, it is non-ionizable. It's not completely ionizable. It is actually, we can say it is non-ionizable. So when you consider primary valency, it is completely ionizable. When you consider secondary valency, it is actually non-ionizable. Okay, it is actually non-ionizable. Okay, so yes, so here you can see primary valency. So primary valency, what is actually primary valency means? It is actually oxidation number. Okay, so we know that oxidation number. So oxidation number is actually primary valency. Then what is secondary valency means? Secondary valency means coordination number. Okay, coordination number is secondary valency. Okay, coordination number da secondary valency. Primary valency is actually oxidation number. Okay, oxidation number coordination number. Clear alla? ஏதாச்சும் டவுட் இருக்கா? கிளியரா? ஏதாச்சும் டவுட் இருக்கா? So next here you can see homoleptic complex and heteroleptic complex. So நமக்கு தெரியும் coordination compounds la actually அந்த coordination compounds two complex compounds divide பண்ணிருக்கு. One is homoleptic compound or complex or and the second one is heteroleptic complex. So homoleptic complex na it is very simple. The ligands, okay, same ligands da irukku. Okay, same type of ligands irunda we can say that it is homo. Homo means same. Okay, homo means same. So here you can see same type of ligands. Okay, same type of ligands da ennada homoleptic. Here you can see Cn 6 times is there. Okay, Cn 6 times is there. Only Cn is there. Okay, Cn cyanide mattumda inga ena liganda irukku. So when you consider heteroleptic complex, so heteroleptic complex or heteroleptic compound, coordination compound nu sonna enada, so hetero means obviously hetero means it's different. Okay, here you can see different coordination, different compounds, that is different ligands. Here you can see, so here you can see chlorine and here you can see NH3. So it is different. Okay, chlorine is 3 times and NH3 is 6 times. Okay, so here you can see different number of different type of ligands. Okay, different type of ligands. That is actually heterolytic complex. I hope it's clear. Clear ada? Enna heterolytic complex, enna homolytic complex nu clear ah? Edachu doubt iruka? I hope it's clear. இது எல்லாமே important தான். Then we are moving to oxidation number. Okay. So when you consider what is oxidation number, it's very simple. So the oxidation number of a central atom in a complex is different as the charge. Okay, it's very simple. So oxidation number normally nama calculate pannulla oxidation number. So when you consider, so here we can consider the, or we can calculate the oxidation number of iron. So here we are taking it as X. Okay, so cyanide oda oxidation number enna, idu ellame by heart pannunu. Okay, cyanide oda oxidation number is actually -1. So how many cyanides are there? So 6 cyanides are there. So minus 1 into 6. Okay, minus 1 into 6. Okay, that is equal to 0. And one more thing, here you can see potassium is also there. Okay, potassium is also there. So I will write here. Okay, K4 FeCN 6 times. So we should find the oxidation number of iron. How we will calculate? So we don't know the oxidation number of iron. Okay, so we can take it as X. Okay, we can take it as X. So here I am taking plus 1 into 4. Okay, plus 1 into 4 plus iron. We don't know the oxidation number, so we can take it as X plus cyanide CN group oda oxidation number is actually it is -1. So how many CN is there? 6 CN is there. So equal to 0. So you can calculate 4 plus X plus 6 minus 6 equal to 0, and X is equal to 6 minus 4, you will get plus 2. So the oxidation number of iron is actually plus 2. I hope it's clear. Edachu doubt irukka? So I will give you FeCN 6 times, FeCN 6 times 4 minus. So tell me, calculate the oxidation number of iron. So calculate the oxidation number of iron. Calculate the oxidation number of iron. Hello Yash. Hello Zaina, Mera, Navya. No ma'am. So I hope it's clear allada. Again plus 2. Again plus no. Yes, yes, tell me Yash for me or any other students. Yes, now let me calculate. I don't know. So I am taking it as X and CN is -1 into 6. So you will get, it's actually 4. Okay, -4. So X into, not X into X plus -6 is equal to -4. So X equal to -4 plus 6. I think it's plus 2. Not I think, it is plus 2. Yes, correct. Yes, Satnivana Satya. Am I right? मैं देख लिया मेरा. Yes, I watched. Yes, Satnivana Satya. I have seen Satnipana Satya. It's a Hindi serial. So, like childhood, like lots of Hindi serials irundadukku. Hey Rishta Kya Kalata Hai, Ashiki 2 and Ashiki Nagin. Oh my god, lots of Hindi serial. I'm a Hindi serial fan. Appo illa appo. School la padikumbodhu, college la irukumbodhu, and yo is pyar ko kya naam du. Okay, yes. Adella oru kaalam. Yeah. So tell me, you can calculate the oxidation number of, ma'am, Vidya is my favorite. Vidya. Yeah, I know Vidya. Actually, Vidya is actually good. அந்த டைமில் எனக்கு வித்யா ஒரு என்ன what வித்யா ஆக்சுவலி ஒரு எந்த வில்லன் மாதிரி தான் தெரிஞ்சது. இப்போ எனக்கு வித்யா தான் கரெக்டுன்னு இப்போ ஓகே இந்த ஸ்டேஜில் வித்யா ஆக்சுவலி வித்யா வாஸ் ரைட். Yeah, here you can see அந்த கேரக்டர் நேம் எல்லாமே மறந்து போயிருக்கு. Yash, I can't understand what is going on. So you can calculate the coordination number of cobalt. So yes, X plus Cl minus 1, okay, minus 1, and it's a neutral ligand, minus 1. So yes guys, it is plus 3, it is minus 3. It is actually neutral ligand, okay, it is actually neutral ligand. So here the oxidation number of cobalt is actually plus 3, okay, oxidation number of cobalt is actually plus 3, okay, oxidation number of cobalt is actually plus 3. So next is actually ligand and denticity. It is very, very important, okay. So ligand and denticity, it is very, very important. Guys, what is ligand and what is denticity? So we know that ligand means, so it is actually electron donors, okay, electron donors. So it will give electron to central metal atom, okay. So that is electron donors. The anion, cation or neutral molecule which combine with central ion, okay, which combine with central ion to form complex ion are called ligands, okay, called ligands. After watching this, yes, you can definitely answer NEET க்கு definitely answer பண்ண முடியும் இந்த lecture பார்த்ததுக்கு அப்புறம், because 2026ல அவ்வளோ ஈஸியான ஒரு question கேட்டிருக்கு, அது சேம் கான்செப்ட்ல இருந்து தான் கேட்டிருக்கு, okay. So I think isomerismல இருந்து வந்த question, okay. Where find this notes. So yes, telegram channel இருக்கு. So telegram channelல உங்களுக்கு download பண்ண முடியும், okay. Yes, anion, cation or neutral molecule which combine with central atom to form complex ion is called ligands, okay guys. I hope it's clear. What is ligand? Ligand means electron donors, okay. It is either anion or cation or neutral atom, okay, either anion, cation or neutral molecule or atom, okay. Then what is denticity? What is denticity? This is very important, okay. You can expect question from denticity, okay. So number of lone pair donate to central metal atom to form coordinate bond is called denticity, okay. Number of lone pair atom. So எவ்வளோ number of lone pair atom donate பண்ணி இருக்கு, okay. Number of lone pair donate to central metal atom to form coordinate bond is called denticity, okay. To form coordinate bond is called denticity. So denticity la, okay, when you consider ligands, so ligands different type என்ன டிவைட் பண்ணி இருக்கு, okay. Ligands என்ன different type divide பண்ணி இருக்கு. First one is actually monodendate ligand, okay. First one is actually monodendate ligand. என்னடா what is monodendate ligand means? So monodendate ligand is also known as unidendate ligand. So mono uni, what is the difference, like what is the similarity? So mono means one, so uni means one. So here monodendate ligand can donate a pair, that means only one pair of electron, okay, only one pair of electron to central metal atom, okay, only one pair of electron to central metal atom. That is actually monodentate ligand or unidendate ligand. I hope it's clear. I hope it's clear. So I will tell you, I will give you some ligand or a list. Okay. So idu ellame important da. If you want, you can take the screenshot. Okay. Because idu in the like ligands. Okay. Anionic ligand, cationic ligands and neutral ligands are very important with their charge. Okay. Charge is also very important. So here you can see X. Okay. So halogen molecule, so halido, so normally we will say halido, that means fluorido, chlorido, bromido, iodido. So here you can see the charge of halogen compound, halogen atom is actually -1, okay. So it is, guys, what is this? Yash. So it is actually -1. So here you can see fluorido, chlorido, bromido, iodido. Okay. So everything is actually -1. Okay. When you consider halogen group, okay, halogen atoms, so that charge of halogen atom is actually -1. Okay. So next is actually OH. What is OH means? That is hydroxido. Okay, hydroxido. Yes, hydroxido. So that is OH minus. So that is actually the charge of hydroxido is also -1. Okay, the charge of hydroxido is also -1. Next is hydrido. Okay, next is actually hydrido. Hydrido means H minus. Okay, H minus. So hydrido is actually -1. Okay, and when you consider CN, cyanido. Okay, normally in a cyanido illana cyanido nu dhaan sollu. Okay, cyanido C. Okay, so cyanido C means, so this is actually Cn minus. Okay, Cn minus. So adode charge ane, this is very important. So just take a screenshot and by heart the ligand names. Okay, so next is, here you can see cyanido. Okay, cyanido C irukku. Okay, what is the meaning of cyanido C? So the speciality of Cn, okay, the speciality of Cn is actually here carbon contain lone pair and nitrogen also contain lone pair. That means carbon can also donate, nitrogen can also donate. Okay, nitrogen and carbon can donate. Okay, so that is the reason here we are writing cyanido C. Cyanido C means in this bonding carbon is actually donating a pair of electron. Okay, carbon is actually donating a pair of electron. So when you consider NC minus, okay, NC minus. So here we can say that it is cyanido N. Okay, cyanido N. Cyanido N means here nitrogen is donating 1 electron. Okay, here nitrogen is donating 1 electron, or we can say that isocyanido. Okay, this is also NC minus means it is isocyanido. It is also -1. Okay, so next is NO2 minus. So NO2 minus means here nitrogen can donate and oxygen can also donate electron. Okay, nitrogen and oxygen have lone pair of electron. So nitrogen and oxygen can donate electrons. Okay, electron pairs to ligand, not ligand, to central metal atom. Okay, so here you can see NO2 minus. So it is actually nitrato N. Okay, nitrato N. So here nitrato N means here the nitrogen is giving 2 electron. Okay, or nitrogen is giving a pair of electron to central atom. Okay, so the charge is actually minus. And here you can see this is same ada. Okay, NO2 minus. Here it is NON. Okay, sorry, NON I am saying. ONO. Okay, ONO. So same only, it is also NO2 minus. Okay, it is also NO2 minus. But here you can see it is nitrato O. Okay, what is nitrato O means? Here oxygen is donating electron. Okay guys, here oxygen is donating electron. So that is the reason it is nitrato O. Okay, it is nitrato O. So the charge is actually -1. And next is SCN minus. What is SCN minus? Thiocyanato S. Okay, thiocyanato S. What is thiocyanato S? It is also same. Here sulfur is donating electron. Okay, sulfur is donating electron. And here nitrogen can also donate electron. Okay, here nitrogen can also donate electron. So NCS minus. Okay, NCS minus means that is thiocyanate N. Okay, thiocyanate N. Here nitrogen is donating electron. Here sulfur is donating electron. Charge is similar, same only. And next is NH2 minus. Okay, listen carefully. That is NH2 minus. NH2 minus means that is amido. Okay, amido, the charge is actually -1. Then next is actually NH2 minus. Okay, NH2 minus means imido and N3 minus means nitrido, and that is here the charge is different. Okay, here you can see for imido it is -2 and nitrido it is -3, and when you consider N3 minus, okay, this is N3 minus, so here you can see 3 nitrogen is there. Okay, 3 nitrogen is there. Here only 1 nitrogen is there and the charge is actually 3 minus. Okay, and here 3 nitrogen atom is there, the charge is actually minus. Okay, so listen carefully. Okay, so N3 minus means that is 3 nitrogen atom and minus means, okay, N3 molecule with nitrogen with negative charge means, that is azido. Okay, azido. Okay, azido oda charge actually it is -1. Okay, azido is actually -1. So, and here you can see NO3 minus. NO3 minus. What is NO3 minus? NO3 minus means this is nitrato. Okay, this is nitrato. Okay, NO3 minus nitrato, and nitrato oda charge ennada -1 da. And next is SO4 2 minus. Okay, SO4 2 minus is actually sulfato. Okay, sulfato oda charge ennada -2. Okay, yeah, Gopika ma'am irukku. Yeah. So, yes, here you can see CO3 2 minus. Yes, CO3 2 minus. CO3 2 minus means carbonato. Okay, carbonato. So, carbonato oda charge actually -2, and next is S2O3 2 minus. S2O3 2 minus is actually thiosulfato. Okay, thiosulfato, it is also -2. Okay, thiosulfato, it is also -2. Next O2 minus. Okay, oxygen atom with a 2 negative charge. Okay, with a 2 negative charge, that is oxido oda charge ennada, it is -2. And here S2 minus, that is sulfido is also -2, and CH3COO minus, that is acetato oda charge ennada -1 da. Okay, so first in anionic, idu ellame anionic ligand. Okay, so then we are moving to neutral ligand. Neutral ligand, it's very simple. The charge is actually 0. Okay, water molecule, that is we can't say water. Okay, instead of water we will use aqua. Okay, so naming எழுதும்போது, okay, ஒரு IUPAC naming coordination compounds ஓட IUPAC naming எழுதும்போது, so அதில we should use aqua, not water. Okay, not water, we should use aqua. And next is NH3. Okay, NH3 னு சொல்லும்போது that is amine. Okay, NH3 means that is amine. NO means that is nitrosyl. Okay, NO nitrosyl, CO carbonyl, and PH3 is phosphine, and here you can see C5H5NPY, that is PY means pyridine. Okay da, pyridine. So it actually pyridine da. Okay, this is actually pyridine, and இது எல்லாமே 0. Okay, pyridine and aqua, phosphine, carbonyl and nitrosyl. So இது எல்லாமே என்னடா, இது எல்லாமே neutral ligand. Neutral ligand means charge should be 0. Okay, charge எப்பவுமே 0 ஆ இருக்கும். And here you can see CH3NH2. Okay, CH3NH2 means methenamine. Okay, methenamine or methylamine. So we will normally use methenamine. Okay, methylamine normally use பண்ணாது. So you can use methenamine. Okay, 0. And PH, this phosphorus. Okay, phosphorus with the PH. Okay, that means phenol, 3 phenols. Okay, so that is triphenylphosphine. Okay, triphenylphosphine. So adu ennada neutral ligands da. You should by heart all the neutral ligands oda names. You should by heart all the anionic ligands oda name. And cationic ligands ungalku actually 3 cationic ligands da irukku. Okay, so 3 cationic ligands la NO plus, NO2 plus and NH2, NH3 plus. Okay, so first one is nitrosonium, nitronium, hydrazinium. Okay, ellame plus 1 da. Okay, nitrosonium, hydronium and nitrosonium and nitronium and hydrazinium. Okay, so ellame ennada plus 1 charge la da irukku. Okay, ellame plus 1 charge la தான் இருக்கு. ஸோ பை ஹார்ட் பண்ண வேண்டியது, ஃபோக்கஸ் பண்ண வேண்டியது ஆனியானிக் லிகேண்ட் அண்ட் நியூட்ரல் லிகேண்ட். இது 3 தானே சிம்பிளாக படிக்க முடியும். ஸோ ஆனியானிக் லிகேண்ட் அண்ட் நியூட்ரல் லிகேண்ட் இஸ் வெரி வெரி இம்பார்ட்டண்ட். ஸோ எஸ், தென் ஸோ ஆல்ரெடி நம்ம மோனோடென்டேட் இல்லைன்னா யூனிடென்டேட் என்னன்னு ப்ராப்பராக படிச்சிருக்கு. வாட் இஸ் மோனோடென்டேட் மீன்ஸ்? ஸோ மோனோடென்டேட் மீன்ஸ் carbon and oxygen can donate electron. Carbon and oxygen will donate in electron. Okay. So Gobinga mamoda live ungalku 7:30 ki irukku. Okay, 7:30 ki live irukku, no worries. Okay, yes. N and bidentate ligand. Okay da, what is bidentate ligand? What is monodendate ligand? So monodendate ligand means only one atom will give or one pair of electron. Okay, donate that molecule, that ligand will donate one pair of electron. Okay, that is actually monodendate ligand or that is actually monodendate ligand or unidendate ligand. Okay, then what is bidendate ligand means? So from the name we can easily clear understand panna mudiyum. Bidendate ligand means here that ligand will donate two, okay, two donor atom is there. Okay, so 2 donor atom is there, so 2 donor site is there. The ligand is said to be bidendate. Okay, bidendate or didendate ligand. Okay, either bidendate or didendate ligand ungaloda textbook la question paper la theru bidendate or didendate ligand nu sollu. Okay, so இந்த மாலிக்யூல்ல பைடென்டேட் லிகேண்ட்ல 2 டோனர் சைட் இருக்கும். ஓகே, 2 டோனர் சைட் இருக்கும். ஓகே, 2 டோனர் சைட் இருந்தா we can say it is bidendate ligand or didendate ligand. So it can donate 2 pair of electrons to the central metal atom. Okay, so it can donate 2 pair of electrons. So what will happen? So obviously it can donate 2 pair of electron. Okay, 2 pair of electron to the central metal atom. Okay, I hope it's clear. Then other examples now. Okay, so when you consider C2O4 2 minus, so C2O4 2 minus oda, that is oxalato. Okay, oxalato. So oxalato oda speciality enna? So here you can see COO. Okay, COO. So in the oxygen, so oxygen melata enna irukku, negative charge irukku. So that means we know that this oxygen contain the electron density of oxygen is more. So oxygen is ready to donate electron. Okay, so here this 2 oxygen will donate electron. Okay, 2 oxygen atom will donate electron. Okay, I hope it's clear. Then this is donor atom is actually 2 oxygen atom. Okay, donor atom is actually 2 oxygen atom is actually donor atom. Then next is ethyl diamine. Okay, ethylene diamine, ethyl diamine alla ethylene diamine normally we will represent with En. Okay, so ethylene diamine. Okay, or we can see ethane 1,2 diamine. Okay, ethylene diamine or ethane 1,2 diamine sollalam. Okay, ethane 1,2 diamine. So here you can see inga 2 nitrogen is there. Okay, so in the nitrogen la enna irukku, lone pair of electron. Nitrogen contain lone pair of electron and that nitrogen is ready, that both nitrogen is ready to donate a pair of electrons. So here this nitrogen is ready to donate a pair of electron, and here also this nitrogen is ready to donate a pair of electron. So when you consider ethylene diamine, so ethylene diamine la 2 donor site is there, okay, 2 donor site is there. So the donor site is actually nitrogen, okay. Yes, okay. So next is donor atom, okay. So 2 nitrogen atoms, actually 2 donor atom, and another example is glycinato, okay. Glycinato is another example of didentate ligand or bidentate ligand. What is glycinato? So that is NH2 CHCOO minus, okay, NH2 CHCOO minus, that is glycinato. So glycinato 2 donor site is there, one is nitrogen and another donor site is oxygen. So I hope it's clear. Clear alleda? Yedachu doubt iruka? Clear alleda? Yedachu doubt iruka? Is it clear, ma'am? Yes, the oxalate neutral da. Then we are moving to polydentate ligand. So when you consider poly means yes, and the namely irukku more than 2, okay. So okay, no doubt, okay, clear, okay, clear, okay then. So polydentate ligand, what is polydentate ligand? So poly means here you can see more than 2 donor sites, okay, here you can see more than 2 donor site is there. So can donate more than 2 pair of electrons to the central metal atom, okay. So it can donate more than 2 electron pair of, okay, electron pairs to central metal atom. So when you consider hexadentate, okay, hexadentate, it's another type. Hexadentate la you can see this oxygen can donate electron, 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 1 2 3 4 oxygen can donate electron, okay. This is actually EDTA, okay, this is actually EDTA, okay, EDTA 4 plus, okay, EDTA 4 plus, okay. Ethylene diamine, yes, okay. So ethylene diamine tetraacetate, okay, acetate, okay. So ethylene diamine tetraacetate, EDTA 4 minus, okay, EDTA 4 minus. I hope it's clear. So donor atom is actually 2 nitrogen atom and 4 oxygen atom. This 2 nitrogen atom also contain lone pairs. So 4 plus, yes, total 6 sites are there. That is actually hexadentate, okay, hexa means 6. So 6 sites are there, okay, 6 sites are there. Next is ambidentate ligand. This is very important, okay. Ambidentate ligand, okay, maybe they will give like questions based on this, okay. Ambidentate ligand. So ambidentate ligand na, they are actually monodentate ligand da, okay. But adukku actually more than 2 sites irukum, donor atoms irukum, okay, more than, when you consider cyanido, okay, cyanido and isocyanide. So cyanido la we know that carbon will donate, okay. Isocyanide la nitrogen will donate, okay. So in the cyanido la carbon தான் donate பண்ணும் electron, isocyanide la nitrogen தான் donate பண்ணும் electron, okay. So here actually 2 donor site is there, okay, 2 donor site is there, but at a time, okay, at a time, ma'am, yes ma'am, என்னடா கீர்த்தனா, more than 2, என்னடா question எனக்கு புரியல கீர்த்தனா. Yes, sir, thiocyanate S உம் thiocyanate N உம் இருக்கு, okay. So yes, same question. So yes, same question asked, yes, from this concept here. நான் already சொல்லிருக்கு. So ambidentate ligand is more important, okay. So yes, எல்லாத்துல இருந்து ஈஸியா 8 மார்க் இல்லனா ஒரு 3 ஹவர்ஸ்ல இந்த சாப்டர் ப்ராப்பரா முடிக்கலாம், okay, கான்செப்ட் கம்ப்ளீட்டா முடிக்கலாம். If you are doing ஒரு 20 or 30 question from this chapter means சூப்பரா உங்களுக்கு 8 மார்க் இந்த சாப்டர்ல இருந்து லாக் பண்ணலாம், okay. Yes, இந்த question again கேட்டிருக்கு. Yes, I can understand. Loading, ma'am. Again loading. Oof. Seriously guys, perfect, I think perfect. Sure. Oof. Seriously guys, No. No da. It's not loading.
Seriously, guys?
No. No da. It's not loading. Fine, ma'am. Yeah, now okay. Okay. Fine. Okay da. So okay. So here you can see this is actually, ma'am, any. No, nobody is speaking at all. So yes, so here you can see when you consider Cn. So Cn la carbon ku என்ன electron donate பண்ண முடியும், nitrogen க்கு electron donate பண்ண முடியும். But at a time la one donor site மட்டும்தான் electron donate பண்ணும். Okay, at a time la one site மட்டும்தான் என்ன electrons donate பண்ணும். அதுதான் என்னடா ambidendate ligand. Okay, ambidendate ligand is actually a monodendate ligand. Okay, ambidendate ligand is actually monodendate ligand, but which have more than one donor atom. Okay, which have more than one donor site or donor atom, but can coordinate to the central metal atom or ions using either one of them at a time. Okay, at a time la one atom da electrons donate பண்ணும். Okay, no, it's perfect. And yes, NO2 NO, yes, correct da, correct. Then we are moving to isomerism da. Isomerism. No, first we are moving to naming. Okay, illa isomerism la coordination number. Okay, so we know how to calculate coordination number. So coordination number calculation is also very important. Okay, coordination number எப்படி calculate பண்ணணும்? So அதுக்கு ஒரு சிம்பிளான equation இருக்கு. Okay, coordination number calculate பண்றதுக்கு ஒரு சிம்பிளான equation இருக்கு. That is number of monodendate ligand. So, suppose இப்போ number of monodendate ligand மட்டும்தான் இருக்குன்னு நினைச்சுக்கோங்க. So then coordination number is actually number of monodendate ligand. Just assume that bidendate ligand is there. Then you can write 2 into bidendate ligand. If tridendate ligand is there means 3 into tridendate ligand. So you can calculate the coordinate number for this molecule. Calculate the coordination number for this molecule. Calculate the coordination number for this molecule. Come on. Come on da. Come on, calculate coordination number. Why 2 tetrahedral? Complex generally not shows cis trans. I will explain that here. ഇവിടെ இருக்கு, இங்க இருக்கு. Okay, I will tell you that. It's very simple. Coordination number. So this is actually monodendate ligand. Okay, it's a NH3. When you consider NH3 la nitrogen mattumda electron donate பண்ணும். So it's a monodendate ligand. So it is actually 6. Okay, so when you consider this molecule, இதோட value என்னடா? இதோட value என்ன? Cn 6 times. You can calculate. Ada, what is the speciality of CN? CN oda speciality ennada? CN oda speciality enna? Again 6. So what is the speciality of CN? Here CN can donate 2 electron and nitrogen can also donate 2 electron. Okay, so it's a didendate ligand. Okay, didendate ligand oda under la dhaan varum. Okay, here you can see enga poi didendate. Yeah. So when ligand can bind through 2 donor atom, the ligand is said to be bidendate. Okay, so it can donate. Okay, it can donate a pair of electron. Okay, normally inge ennada? So paatha theriyum. Yes. So here oxalato and oxalato is there and ethylene diamine is there. So that means ethane 1,2 diamine, and this is also glycinato ellame example da. So yes. So yes, it's monodendate ligand. Yes, correct da. So idukku actually 2, okay, carbonukkum 2 electrons donate panna mudiyum and nitrogenum 2 electron donate pannum, but it is actually bidendate ligand. Okay, it's bidendate ligand illa ambidendate ligand. Okay, it's ambidendate ligand. So at a time one donor site mattum da irukku. Okay, at a time one donor atom mattum da enna electrons donate pannum. It's a ambidendate ligand. Okay, it's a ambidendate ligand. So I hope it's clear. Then we are moving to yes, IUPAC nomenclature. Okay, so in the IUPAC nomenclature la irundhu question varradhukku chances irukku. Okay, so IUPAC naming la irundhu, okay, coordination compound oda IUPAC naming question la irundhu it's ambidendate ligand. It's ambidendate ligand. Already told you na, ambidendate ligand. It's ambidendate ligand. Sadhana, it's clear. Sadhana, clear? Sadhana, clear? Sadhana, I hope okay. CN is mono or bidendate. It is monodendate, not bidendate. It is monodendate. It is monodendate. At a time, one side la irundhu again loading. Seriously da? Now fine. I don't know why. So I think கேட்க முடியுது இல்லடா? Fine ma. Okay da. Okay. So clear alle ambidendate monodendate sadhana? Yes. Okay. Then we are moving to IUPAC naming. Okay, IUPAC nomenclature. Okay, IUPAC nomenclature. Yeah, it's fine. Ask to Gopika ma'am. Hurry. So nomenclature, okay, nomenclature rules. Okay. Hey da. Okay, so first rule, okay, first point is actually, I can't see the point. The coordination compound is ionic, then the cation is named first followed by anion. Okay, so when you consider, if you are writing a ionic compound, okay, if you are writing an ionic compound, so sodium chloride NaCl, okay, so Na is plus and Cl is minus, so it is actually idoda name enada, sodium chloride. So formula எழுதும்போதும் அதோட proper name எழுதும்போதும் you can see first we are writing cation. Okay, first we are writing cation. In the same way, in coordination compounds also, first we will write cations. Okay, if name எழுதும்போதும் இல்லனா ma'am. Yeah, I can understand that. How was trauma? Yes, I can understand. I think Navya actually நமக்கு actually same தான் இருக்கு. ஓகே, அவங்க பேடிச்சே நமக்கு மார்க் கொடுக்கும். எனக்கும் அந்த மாதிரி தான். எனக்கு ட்ராமா பேனிக் ஆகும். ஸோ அப்போ அவங்க பேடிச்சே அவங்க ஓகே நீ ஆன்சர் சொல்ல வேண்டாம், ஐ வில் கிவ் யூ மார்க்னு சொல்லும். ஓகே, தேங்க்யூ சார். அந்த ஃபீல் சேம் யா சேம் sodium chloride. Okay, so sodium chloride, and first we will write cation. Okay, if you are writing what trauma, ask to Navya. So we have same character, same character, panicking. So when you consider in a formula எழுதும்போது இல்லனா if you are writing the name also, first we should write cation. Okay, first we should write cation. So same here also. Okay, same. Okay ma'am, meaning Okay, so here you can see when you consider nomenclature inga IUPAC and a coordination naming பண்ணும்போது first you should write, okay, first you should write in a cation oda name. Okay, suppose if it is formula or if it is in a name எழுதும்போது you should write cation name first. So first this is clear. Then we are moving to second rule. So second rule is in the coordinate sphere, the first ligand are written in alphabetical order. Then the central metal atom, okay, IDE, okay, atom ide is replaced by ido and 8 is replaced by A2. Okay, so coordination sphere, we know that this is coordination sphere allada. So in the coordination sphere, the first ligand are written alphabetical order. So nama first ligand or maybe or 2-3 ligands alla irukumbodhu you should write, okay, you should follow alphabetical order, okay, alphabetical order. Then the central metal atom, okay, central metal atom eppadi eduthanuda. So IDE nu last varuduna, okay, central metal atothula IDE nu last varuduna you should change enna replace பண்ணனும் ido னு replace பண்ணனும் and 8 வந்தா you should replace with A2. Okay, so argentinate, okay, so some like metals ஓட அதோட என்ன latin name வரும், okay, latin name எல்லாம் வரும்போது 8 வரும்போது ide வரும்போது ido change பண்ணனும், 8 வரும்போது A2 change பண்ணனும். Okay, so if the same ligand is present, okay, if the same ligand is present more than once, okay, so we know that like CN 6 times, okay, CN 6 times illana ena water H2O 2 times, okay, 2 times nu solumbodhu how we will write H2O 2 times, it's very simple. Diaqua you can use di, tri, okay, prefix la you can use di, tri, tetra, di, tri, tetra. Okay, so when you consider H2O 2 times means you can write diaqua, okay, diaqua. Okay, I hope it's clear. So next point, in the point clear nu nenikira, then we are moving to next point. If di is already used, then the prefix will be bis, tris, okay, tetrakis, okay, already used nu solumbodhu when you consider ethylene diamine, okay, so ethylene diamine nu sonna enna, it is a ligand, okay, En, okay, ethylene diamine. So idu En actually 2 times irukku, okay, so how we will write diethylene diamine எழுத முடியுமா, diethylene diamine னு எழுத முடியுமா, so it is not possible, okay, at that time you can use bis, tris, tetrakis. So when you consider ethylene, okay, ethylene diamine 2 times, so how we will write, you can write bis ethylene diamine, okay, bis ethylene diamine you can write. Okay, I hope it's clear. Then third point, okay, after writing ligands, so neenga complete ligand ella எழுதி முடிச்சதுக்கு அப்புறம் after writing ligand the central metal atom you should write. Okay, you can write the central metal atom name, so written along with its oxidation number. So எப்படி எழுதணும், central metal atom name and bracket la oxidation number எழுதணும் latin la, okay, latin number systemல, okay, latin number system maybe 2 1, okay, 3 or something, okay, you should write the oxidation number. Okay, so metal central metal ஓட name எழுதும்போது you should write என்னடா latin name. Okay, so I hope it's clear. Then we are moving to next point. If the coordinate sphere is anionic, it's very important. If coordinate sphere is anionic, anionic means negative charge. Okay, if coordinate sphere is actually negative charge, so yes, if coordinate sphere is negative charge, then the central metal atom name end with 8. Okay, central metal oda name, okay, so என்னடா anionic sphere, okay, suppose anionic sphere la தான் இருக்கு, okay, sphere என்ன negative charge, okay, sphere என்னடா negative charge ல இருந்தா, so if the coordination sphere is anionic, then the central metal atomோட name எழுதும்போது you should end with ATE, 8 வச்சு end பண்ணனும். Okay, we can do some examples. So next is actually O suffix is provided to the name of anionic ligand. Okay, anionic ligand. Anionic ligand varumbodhu negative ligand. Okay, anionic ligand varumbodhu suppose O suffix is provided to the name of anionic ligand and EM you can change to EM. Suffix is provided to the name of cationic ligand. Okay, so cationic ligand ku EM and anionic ligand ku O. Okay, end suffix la appdi pannanu. Okay, okay, I hope it's clear. I hope it's clear. So here you can see some metals or names. Okay, iron, ferrito, and silver, argentinate, gold, orate, plumpate. So yes, so on. So you can by heart. So yes, write the name of this molecule. So Sikrama, you can write the name of this molecule. Come on. So just write the name of molecule. So before that, I will give you a 5 minutes break. With 5 minutes break, I want to drink water. So I will give you a 5 minutes break. What is time now? Okay. Minutes, okay. I'm here. I'm here. Yes, 6, 7. Ma'am. Oh, can see just a second. I'll drink water. So 50 like aidicha. So 50 like aidichina mattuna I will start session. Answers are, let me check 50 likes aidicha illiyana. Yes, 48, 50 agala. What you are thinking the same? What ada? 49. Yes, 49, still 49, still 49. Okay, so yeah, we can start. So இந்த மாதிரி ஒரு moleculeோட ஒரு molecule உங்களுக்கு கிடைச்சிருக்குனா like you can write the names. Okay, so first என்ன இருக்கு? Silver is there and NH3 எப்படி, that is amine. So NH3 51 ஆயிடுச்சா? Okay, nice. So our target is actually 100 ada. Our target is actually 100. இப்போவும் 51 தான் இருக்கு. Okay, target is actually 100. No excuses. 100 வேணும். Hello. So yes, here என்னடா? This is actually negative. Okay, this is actually positive and this is negative. Okay, so this is your sphere is actually positive, that means cation, and that is counterpart is actually anion. Coffee, ma'am. Coffee allada boost. So and yes, NH3 means that is amine. Okay, amine. And next in chlorine. Chlorine na you can write chlorine. So I am writing chlorine. Okay, so how we will write the name? First you should write the name of ligands. Okay, so first cation la irundha da start பண்ணனும். So cation la first start பண்ணும்போது ligand la irundha. Okay, same pinch for boost. Oh, boost, nice ma'am. Okay da. So yes, we can start from amine. Okay, so you can see that 2 amines are there. So you can write diamine, and after that you can write a central metal atom. Okay, central metal atom. Okay, so central metal atom is actually silver. So you can write silver. You should write the oxidation number also. Okay, oxidation number also. Okay, you should write oxidation number and ennada chlorine. Okay, so chlorine. So how we will calculate oxidation number? Tell me how we will calculate oxidation number. How we will calculate oxidation number? How we will calculate oxidation number? Boost is the secret of Aswathi Mam's energy. Ada. Huh. Yes, now boost is my secret. No doubt. Navya. Hey, two Navyas are there. Navya, Sheem and I thought that Navya and this Navya same only because we have panicking character. We are same. Yeah. So now you can calculate the oxidation number. Hema, no Hema. How we will calculate oxidation number, ada? No ma'am, same. Okay, same. Yeah. So how we will calculate oxidation number? Yeah, we know that oxidation number of chlorine is actually -1, and for ammonia, like for amine, Okay, for amine it is actually its neutral ligand 0. So yes, if you're balancing means it's -1 and it is +1. So you can write. What is the correct answer? It is 1. I hope it's clear. Okay. Okay. So we can write next molecule. You can write the next molecule. So first you can write potassium. So I am writing normal names. Okay. Potassium, nickel, El. Okay. And chlorine. How we will write the name? Sorry ma'am, it's +1. Yeah, it's +1 only. X plus 0 is -1. Yes, correct. So x is equal to potassium tetrachlorochlorine. Okay, we can write. Okay, so first we should start with cation only. Okay, we should start with cation. Yeah. So here cation is potassium. Okay, so you can write potassium. Then we can check the square part, that is our sphere. Okay, coordination sphere. So coordination sphere la first we should write ligand. So here the ligand is actually chlorine. Okay, chlorine is the ligand. So we can write, and guys here you can see chlorine is actually in negative part. Okay, so anion la da chlorine irukku. Okay, this is actually negative and this is actually positive. Okay, anion la da enna irukkuda chlorine irukku. So anion la ligand varumbodhu. Okay, anion la ligand eludhumbodhu how we should write? Yes, you should write ido. Okay, IDO, you should use ido. Okay, so yes, chlorido. Okay, so we can write, yeah, how many chlorine is there? 4 chlorine is there. Okay, so 4 chlorine means tetrachlorido. Potassium chlorido. Yes, and here you can see nickel. Okay, here you can see nickel, but it is in anion side. Okay, anion part means you can write nickelate. Nickelate with oxidation number. How we will calculate oxidation number? So for chlorine, we know that for chlorine it is -4 and for this it is +2. So for nickel it is +2. Yes, it is 2. Okay, you can write 2. I hope it's clear. Nickelate. Yes, correct. Then we are moving to next molecule. Here you can see another molecule is there, so you can write the name. Come on, Ada. So guys, give tougher ligand. So now you can write. Ma'am, now only I drunk boost alle. So I have lots of energy. Dakshin, you're so late. You're so late. Okay, let me write. Okay, so chromium, aqua, chlorine, What is NO3 means? What is NO3? Name of NO3. What is name of what is name of NO3? That is, yes, it is nitrate. It is nitrate. Okay, so we can write the name. So yes, aqua and chlorine. So you should follow alphabetical order for ligands. So first you can write aqua, and how many aqua is there? 4 aqua is there. So you can write tetra aqua, and next chlorine, 2 chlorine is there. So tetra aqua dichloro, and chromium is there. So how we will write chromium? So you can write chromium only, okay, because it is in positive, that means cation side, okay, it is there in cation side, so you can write chromium. I don't know the oxidation number, we should calculate the oxidation number, and it is nitrate. So we should calculate oxidation number. So for aqua it is actually 0. For aqua it is actually 0. It's neutral ligand. For chlorine it is -2. When you consider NO3 is actually anionic ligand. For it is also -1. So -1, -3, -1, -2, -3, -3. So obviously it is 3. Yeah, I hope it's clear. Not class, we are actually giving plan, okay. So we are giving plan, so you can write, guys, I will give you a molecule, name of the molecule, you can write the formula. I will give you a name of the molecule, you can write the formula. No, Sadhana, clear, ma'am? Gopika ma'am oru live irukkuda. So Gopika ma'am oru live irukku. I know you all are waiting for Gopika ma'am. Gopika ma'am oda live irukku 9 o'clock and 7:30. So proper join pannu, okay. So ini 30 days plan allame irukku. So proper plan allame irukku. So just join pannunga. Yes, you can write the formula. Come on, write. And guys, like the session, quickly like the session. How to find chloro and chlorido? That I will tell you. Chlorido means it should be in a ligand formula irukkanum, okay. Chlorido agumbodhu, and that ligand eppadi irukkanum, ligand negative part la irukkanum, okay. Okay. So tetramine, amine is actually NH3, aqua, tetramine 4, aqua is actually, how many aqua is there? Only one aqua is there. Chlorido, chlorine is there. From here we can confirm that it is a square, okay. That is it is a sphere, okay. And cobalt 3 and chloride, okay. So you can start, first you should write a central metal atom, so CO, and you can write amine NH3 4 times and H2O, and and Cl. How many Cl is there? Only one Cl. Aqua is 1, chlorine is 1, and cobalt is there. Then chlorine. Okay. So guys, how many chlorine is there? Okay. So chlorine has actually 1 ன்னு எழுதி இருக்கு. So chlorine எவ்வளோ இருக்குன்னு நமக்கு தெரியாது. Okay. So we should calculate chlorine ஓட number. Okay. So how we will calculate chlorine ஓட number? This chlorine ஓட number how we will calculate? How we will calculate? Come on. Difference between chlorine and chlorido. Listen carefully. இது உங்களோட cation, anion side. Okay. Anion side la chlorine vanda, it is chlorine. Okay, chloro. We can write chloride. Okay, we can write chloride. And இது உங்களோட என்ன positive part la sphere vanda. Okay, sphere vanda, it will act as a ligand. Okay, sphere enna positive la chlorine ligand vanda, you can write chlorido. Okay, I hope it's clear. So positive part la sphere vandirukku. Okay, positive part la sphere irukku. So here you can see chlorine and ligand enna chlorido nu எழுதலாம். Okay, I hope it's clear. Clear ah? Okay, so we should calculate, next we should calculate number of chlorine. And NH3 4 times means NH3 4 times, it's actually neutral ligand. And H2O, it is actually neutral ligand. Chlorine is actually chlorine 1 தான இருக்கு. Yes, chlorine is actually எவ்வளோ இருக்குடா? So chlorine is actually -1 தான். Okay, so yes, so நமக்கு cobalt ஓட oxidation number already இங்க கொடுத்திருக்கு. It is actually 3. Okay, it is actually 3 னு கொடுத்திருக்கு. So obviously it is +3. So இங்க minus இருக்கு. So what will be the answer? It will be 3 minus அப்போ -2. Balance பண்ணும்போது, okay, neutralize பண்ணும்போது it will become -2. I hope it's clear. So you should write 2Cl. Okay, you should write Cl2. Okay, you should write Cl2. Bunny Maharaj, ma'am. Yeah man, I am good. How are you? You are not attending the session. So guys, next we are moving to very important topic, that is isomerism. Okay guys, it is very important topic. 2026 la NEET க்கு இதில இருந்து தான் question வந்திருக்கு. Okay, cancelled exam ல உங்களுக்கு இங்க isomerismல இருந்து தான் question வந்திருக்கு. I hope it's clear. So this is very important topic. So when you consider isomerism, what is actually isomerism? Guys, 10,000 rupees fine ma'am. எதுக்குடா? For late coming. Quickly smash the like button. I want to see 100 plus likes. Okay, yeah, set it. Come on guys. Who will give 10,000 rupees? Me or you? Kyukka like the session. Yes, Kyukka like the session. Okay. Okay. So here you can see isomerism. So when you consider isomerism is what? It is actually the molecular formula is same. The structure is actually different. Okay. Molecular formula is same, structure is actually different, and the properties is also different. Then we can say it is actually isomerism. Okay, it is actually following isomerism. We can say that. So when you consider isomerism is actually 2 types. Okay, so one is structural isomerism, another one is stereoisomerism. Okay, one is structural isomerism, another one is stereoisomerism. So when you consider structural isomerism again class. Before that I just want to say what is structural isomerism. Okay, so structural isomerism means compound having same molecular formula but different structure. Okay, structure la dhaan difference irukku. Okay, same molecular formula but different structure. That is structural isomerism. Next is actually stereoisomerism. What is stereoisomerism means? So compound have same molecular formula but the spatial arrangement is actually different. That is actually stereoisomerism. So first we are discussing structural isomerism. So when you consider structural isomerism is classified into again 3 type. Okay, not 3 type, 4 type. So first one is ionization isomerism, solvate isomerism or hydrate isomerism, and linkage isomerism, coordinate isomerism. Okay. And when you consider stereoisomerism is classified into 2 types. One is geometrical isomerism, another one is optical isomerism. Okay. So first we can discuss about ionization isomerism. Okay. What is ionization isomerism? So here you can see you want to know my salary, Ada? You want to know my salary? So guys, yes, adukku munadi I just want to add one more point. So guys, we know that, okay, we already started a free crash course, okay, we already started free crash course for our students. So guys, did you join to our crash course? Did you join to our free crash course? Did you join to our, here I can see, did you join to our free crash course? This much LPA. I am not a doctor, da. I am a normal teacher. Just now only GOC completed, ma'am. Oh, really. So guys, here you can see, so join free Re-NEET Crash 2026 course. Okay, it's completely free. So how we will join, guys? So you can join, you can click that link. So here you can click, ma'am, buy now, ma'am, buy now. You now only you just said it's free. Just click. Okay, so you can see. Yes, it's actually by now. So here you can see join, yes. So guys, yeah, you can see 0 rupees. So click here, you will get this free crash course for 0 rupees. Okay, da? So yes, you are VNEET students, so you can click, oh, it's master course. Okay, you can click here. Okay, you can click here, yeah, crash course. So yes, you will get separate physics class, biology class, chemistry class. Okay, so உங்களுக்கு ஃப்ரீயா மேபி எஸ் இந்த மாதிரி ஸ்டூடெண்ட்ஸ் கொஞ்சம் என்ன லைக் இரிட்டேட்டிங் ஸ்டூடெண்ட்ஸ் எல்லாம் ஒப்வியஸ்லி யூடியூப்பில் இருக்கும். ஸோ உங்களுக்கு இல்லை மேம் டிஸ்ட்ராக்ஷன் ஒன்றும் இல்லாமல் எனக்கு ப்ராப்பராக ஃபோக்கஸ் பண்ணி படிக்கணும்னா டோன்ட் வரி. ஸோ ஹியர் யூ கேன் சி ஃபிசிக்ஸ் கெமிஸ்ட்ரி பயாலஜியோட கிளாஸஸ் கிடைக்கும். ஸோ எஸ், ஹியர் யூ கேன் சி ஓகே கெமிக்கல் கைனடிக்ஸ், கோஆர்டினேஷன் நம்பர், general organic chemistry. So இப்போவே போய் join பண்ணிக்கோங்க. So here what you will get means, so here you will get 40 plus free mock test. Okay, full length complete mock test you will get as a free. Okay, ஃப்ரீயா உங்களுக்கு அங்கிருந்து கிடைக்கும். Okay, so அதனால இப்போவே போய் ஜாயின் பண்ணிக்கோங்க. லைக் மோஸ்ட் ஆஃப் த ஸ்டூடெண்ட்ஸும் ஜாயின் பண்ணியாச்சு அண்ட் லிமிட்டட் சீட்ஸ் தான் இருக்குது. இப்போவே போய் ஜாயின் பண்ணிக்கோங்க. ஓகே, ஹியர் யூ கேன் சி. ஸோ இந்த கிளாஸ் வேணும்னா யூ கேன் லைக் இப்போது கோஆர்டினேஷன் காம்பவுண்ட் ஒன் ஷாட் தான் நடக்குது. ஸோ இஃப் யூ வாண்ட் யூ கேன் ஜாயின் லைக் திஸ். ஓகே, யூ கேன் வாட்ச் த கிளாஸ் ஹியர் without any distractions. Okay, without any distractions you can see the class here. So yes da, so idu ungalku konjam kuda useful ah irukum. Yes, so I am closing it. Before that I just want to add one more point. Yes, and here you can see book. Okay, Vedandu oda book irukku. Actually namakita actually 30 days தான் இருக்குது. ஸோ இந்த 30 டேஸில் ப்ராப்பராக நீட் பிளான் பண்ணணும். ஓகே, ஸோ நீங்கள் எகெயின் கண்டென்ட் ஓகே, கண்டென்ட் என்சிஆர்டி லைன் பை லைன் திருப்பி படித்தா உங்களோட மார்க் ஆக்சுவலி இன்க்ரீஸ் ஆகாது. ஓகே, ஸோ ஃபார் தேட் யூ ஷுட் ஃபோக்கஸ் நவ் கொஸ்டின்ஸில் ஃபோக்கஸ் பண்ணணும். ஸோ அதனால் எஸ் நம்பிக்கை Re-NEET AITS. So we are actually providing all India test series book. So idala you will get 2520 question and here you will get 20 full mock test. Okay, 20 full length mock test. So in the full length mock test mattum illa, here we are providing 14 OMR sheet. Okay, so yes, nama exam எழுத போறேன். So அந்த proper atmosphere time management is very important. So time manage பண்ணணும். We know that இந்த வாட்டி actually we got one bonus. Okay, 15 minutes extra கிடைக்கும். So அந்த 15 minutesum proper utilize பண்ணணும்னா நீங்க என்ன பண்ணணும், நீங்க maximum questions practice பண்ணணும். ஓகே, maximum எல்லாருக்கும் இந்த 15 minutes கிடைக்குது. ஓகே, ஸோ ஸ்மார்ட்டான ஸ்டூடெண்ட்ஸ் அந்த 15 minutes ப்ராப்பராக யூஸ் பண்ணும். ஸோ அதுக்காக ஆக்சுவலி we prepared a Re-NEET book. Okay, ஒரு booklet இருக்கு. ஸோ அதில் you will get 2520 questions இருக்கும் and OMR sheet இருக்கு and you will get full length test. Okay, 20 full length test plus 14 OMR sheets, 14 OMR sheets இருக்கு. Okay, so and the price is actually 549 தான். Okay, 549 rupees தான். Yes. Yeah, back to our content. Yes. Yeah. Just a second, Ada. I can see your chat, Ada. Just a second. Yeah, I can see now. Yes, ma'am. Bunny, I can't understand. Bunny, I can't understand. Ma'am, I'm in Karnataka. I can receive book. Yes, sir. And the book actually 6 days la home delivery. Okay, 6 days la within 5 to 6 working days la home delivery இருக்கு. So இப்போவே உங்களுக்கு அது அந்த புக் ஆக்சுவலி இப்போவே பை பண்ணலாம். ஓகே, ஸோ யூ வில் கெட் ஆக்சுவலி இந்த Re-NEETக்காக ஸ்பெஷலாக என்டியோட கைட்லைன்ஸ் வச்சு ப்ரிப்பேர் பண்ண 2520 கொஸ்டின்ஸ் தான் அதில் இருக்குது. ஓகே, ஸ்கேம் ஓகேடா, கமான், நோ ஸ்கேம், பன்னி ஸ்கேம். ஸோ ஐ வில் பன்னி எக்ஸாம் முடியட்டும்டா, அதுக்கப்புறம் ஐ வில் கால் யூ. ஓகே, யா, ஓகே. ஸோ ப்ராப்பராக படி, ப்ராப்பராக எக்ஸாம் எழுது. ஓகே, த கிராஷ் கோர்ஸ், free crash course, there is no fee. Okay ma'am, yes da, no fee. Crash course actually free crash course da. I will give you 5 minutes. Okay, not 5 minutes, I will give you ஒரு 3 minutes. இப்போவே போய் ஜாயின் பண்ணிக்கோங்க. ஓகே, so you can see there. So இப்போவே போய் ஜாயின் பண்ணிக்கோங்க. It's actually completely free crash course. So every day you will get one complete mock test. Okay, actually we are providing 45 full length mock test. So இப்போவே போய் ஜாயின் பண்ணிக்கோங்க. ஆல்ரெடி ஆல்மோஸ்ட் லைக் 2000 ஸ்டூடெண்ட்ஸ் இப்போவே ஜாயின் பண்ணியிருக்கு. ஸோ எஸ், இவ்வளோ ஸ்டூடெண்ட்ஸ் ஜாயின் பண்ணியிருக்கு. ஸோ அவங்களுக்கு எல்லாமே பெனிஃபிட், இந்த ஃப்ரீ பெனிஃபிட் கிடைக்கிது. ஓகே, உங்களுக்கும் இந்த ஃப்ரீ பெனிஃபிட் வேணும்ல, ஸோ மேக்ஸிமம் யூட்டிலைஸ் பண்ணுங்கள். ஸோ வி நோ தட் Re-NEETக்கு அப்புறம் எகெயின் நீட்டுக்கு அப்புறம் எகெயின் Re-NEET வரும்போது அந்த டைமில் நம்மக்கிட்ட மெட்டீரியல் கம்மியாக இருக்கும் அண்ட் ஆக்சசரிஸ் எல்லாமே ஆக்சஸ் பண்ணுறதுக்கு எல்லாமே கம்மியாக இருக்கும். ஸோ டோன்ட் வரி. ஸோ ஹியர் வி ஆர் ப்ரொவைடிங் our library access also. Okay, here we are providing our library access also. So here you will get 100 plus reference book. Okay, 100 plus reference book, MTG order questions, engage order questions and different type of reference book இருக்கு. content wise இல்லைனா questions waseல எல்லாமே different book இருக்கு. ஸோ இவ்வளோ ஸ்டூடெண்ட்ஸ் அதை யூட்டிலைஸ் பண்ணுங்க. பண்ணியிருக்கு. ஓகே, ஸோ உங்களுக்கும் அதை யூட்டிலைஸ் பண்ணலாம் பிகாஸ் இது ஃப்ரீயாக கிடைக்குது. ஸோ இப்போவே ஜாயின் பண்ணிக்கோங்க. ஓகே, எஸ் எஸ், கம் டு த டாபிக். எஸ்டா, எஸ், I forgot. Oja, your name is Oja, yes? Yes. So ionization isomerism. First one is ionization isomerism. What is ionization isomerism? So this form of isomerism arises when the counter ion in the complex salt itself a potential ligand and it can displace ligands which can then become a counterpart. So I will give you example. So here you can see CrNH3 5 times SO4Br, and here you can see CrNH3 5 times ClSO4. So இந்த counterpart இந்த SO4 க்கு counterpart ஆக முடியும் and ligandum form பண்ண முடியும். ஓகே, ligandum vote கிடைக்குமா மேம்? இப்போ நான் லிங்கில் போனால் எஸ் எஸ் இப்போவே ஜாயின் பண்ணடா. enroll successfully. Yeah, this bunny எல்லாருமே அந்த லைக் ஆக்சுவலி ஃப்ரீ ஆக்சஸ் யூஸ் பண்ணுறாங்க. ஸோ இப்போவே போய் ஜாயின் பண்ணிக்கோ. ஓகே, லிங்க் இருக்குது, யூ கேன் see the link there. ஸோ இப்போவே போய் ஜாயின் பண்ணிக்கோ. enroll successfully மேம். யா 52 minutes. Gopika ma'am, yeah, Gopika ma'am oda class irukku. Yes, not class, it's a video. Okay, yeah. So here SO4 will act as a both ligand and counterpart. So அந்த மாதிரி isomerisms தான் ionization isomerism. What is your name? Heda, you don't know my name. I am so sad. I'm sad. So I'm okay. Just find my name. Okay, so SO4 will act as a both ligand and as well as counterpart ion. Okay, so this is actually ionization isomerism. Okay, this is actually, yes, you are a Telugu boy. Yes, here Bunny is a Telugu boy, Navya is a Telugu girl. You can see lots of students, Telugu students here ada. So that is actually structural isomerism. Next is actually solvate isomerism or hydration isomerism. Okay, so hydrate isomerism or solvation isomerism. Okay, solvate isomerism or hydrate isomerism. So here solvate isomerism differ by number of solvate molecule directly bonded to the metal ion and present as free solvate molecule in ionization phase. So here you can see this is the molecule. Okay, this is the molecule H2O, that is aqua 6 times Cl3. So inga Cl3 தான் என்னடா, Cl3 தான் கவுண்டர் பார்ட்டில் இருக்குது. ஓகே, கவுண்டர் பார்ட்டில் Cl3 தான் இருக்குது. ஸோ இங்கே லிகாண்டா வாட்டர் தான் இருக்குது. ஓகே, வாட்டர் லிகாண்டா இருக்குது. ஸோ தென் வாட் வில் ஹேப்பன் டா, ஸோ இந்த வாட்டர் என்ன லிகாண்ட் பார்ட்டில் வரும் அண்ட் திஸ் கவுண்டர் பார்ட் என்ன லிகாண்ட் பார்ட்டில் போகும். யூ கேன் சி, ஸோ ஃபர்ஸ்ட் வாட்டர் மாலிக்யூல் எங்கே வருது, லிகாண்ட் பார்ட்டில் வருது. இங்கே ஆக்சுவலி 6 வாட்டர் மாலிக்யூல் 6 அக்வா இருந்தது. ஸோ ஹியர் யூ கேன் சி 5 here you can see 5 aqua and inga CH3 3 times irundhathu. Here you can see CH3 Cl, not CH3, Cl 2 times irukku. Okay, so in exchange nadakudhu. Okay, ligand and solvate, ligand and here you can see counterpart le exchange nadakudhu. Okay, that is actually solvate isomerism or hydrate isomerism nu vilikkiradhukku reason, call pandradhukku reason, here we are using water to exchange. Okay, so I don't know. So this is similar to ionization isomerism. It is actually similar to ionization isomerism. I hope it's clear. So this form of isomerism is also known as hydrate isomerism in case whether water is involved as solvent. Okay, so water solvent use panna, we can say that it is hydrate isomerism. Okay, water solvent use panna, we can say that it is actually solvate isomerism. I hope it's clear. And then next is linkage isomerism. Okay, linkage isomerism. What is linkage isomerism? So this type of isomerism is due to the change of donor atom of ambidentate ligand used to coordinate with the central metal atom. Okay, so here you can see cobalt NH3 5 times NO2 Cl. Okay, NO2 times Cl. So we know that what is the speciality of NO2? So NO2 is actually a ambidentate ligand. Okay, ambidentate ligand. So in case of NO2, so here nitrogen can donate a pair of electron, or oxygen can also donate a pair of electron. Okay, so first molecule you can see nitrogen is donating electron to cobalt. Okay, first molecule you can see that is first molecule yaare electron donate pannadhu, nitrogen da electron donate pannadhu. When you consider second molecule, here the central metal atom is same, and here the ligand NH3 is same. Okay, NH3 5 times, and it is aqua. It's amine. Okay, amine is 5 times, and here you can see it is actually nitrato. Okay, it is nitrato O. This is nitrato. This is nitrato N, and this is nitrato O. Okay, nitrato N and nitrato O. I hope it's clear. I hope it's clear. I hope it's clear. Yes, even thiocyanate, yes, even thiocyanate, lots of molecules, lots of ambidentate molecules are there. Okay, so it will, when you consider ambidentate molecule means it will possess linkage isomerism. Ambidentate molecule means it will possess linkage isomerism. So I hope it's clear. So guys, everyone quickly smash the like button. So you can see coordination isomerism. Next, okay, fourth type is actually coordination isomerism. So what is coordination isomerism? So here you can see this type of isomerism takes place due to the interchange of ligands between complexes. Okay, so here what is actually interchanging? Ligands are interchanging. Okay, maybe ungalku enna central atom change agra madiri feel agum, but here என்ன நடக்குது, ligands தான் interchange ஆகுது. Okay, and my dear students, here you can see the cation and anion in sphere. Okay, cation and anion in sphere. Okay, ரெண்டுமே என்ன எப்படி இருக்குடா, ஸ்பியர்ல தான் இருக்கு. கேட்டயோனும் ஸ்பியர்ல தான் இருக்கு, ஆனியோனும் ஸ்பியர்ல தான் இருக்கு. ஓகே, ரெண்டுமே கோஆர்டினேட் மாலிக்யூலா இருக்கு. ஓகே, கேட்டயோன் அண்ட் ஆனியோன். ஓகே, கோஆர்டினேட் காம்ப்ளெக்ஸ் அயோன்ஸா இருக்கு. ஓகே, ஹியர் யூ கேன் see cation and anion என்னடா காம்ப்ளெக்ஸ் அயன்ஸ்ல தான் இருக்கு. ஓகே, cation and anions you can see in complex ionsல தான் இருக்கு. And one more thing, here you can see chromium NH3 6 times. Okay, and here cobalt Cn 6 times. So இங்க என்ன சேஞ்ச் வருது, ligand தான் interchange ஆகுது. Okay, there you can see the interchange of ligand, not the central metal atom. Okay, so some students க்கு அப்படி ஒரு ஃபீல் இருக்கும், coordination isomerism னா நார்மலி என்ன central metal தான், metal atom தான், central metal atom தான் interchange ஆகும்னு. That is wrong. Here என்ன நடக்குது, ligandல தான் interchange நடக்குது. I hope it's clear. Yes. Sumitra. Okay, next is stereoisomerism. Okay, next is stereoisomerism. When you consider stereoisomerism, so yes, stereoisomerism is actually two types. One is geometrical isomerism, another one is optical isomerism. What is geometrical isomerism means? When you consider stereoisomerism means it is the molecular formula, everything is same, but the spatial arrangement is different. Okay, spatial arrangement is different. So here you can see first one is geometrical isomerism. So here this type of stereoisomerism arises in the coordination compound due to difference in geometrical arrangement of the ligand around the central iron. Okay, so normally உங்களுக்கு cisum transum தெரியும்ல. So what is cis? Cis means same molecule or same atom in or same atom or same group in same side. Okay, same group or same atom same side ல இருக்கணும். Then we can say it is cis. Okay, here you can see chlorine chlorine same side ல இருக்கு. NH3 NH3 same side ல இருக்கு. Okay, so it is cis molecule. Okay, it is cis molecule. Then what is trans molecules? So you can see in opposite. Okay, same molecule you can see in opposite side. Okay, same molecule or same group of atom. Okay, same group or same atom. Okay, in different side. So here you can see chlorine chlorine opposite side la da irukku and NH3 and NH3. So different opposite side la da irukku, adu da actually trans. So when you consider geometrical isomerism thila cis trans isomerism da irukku. Okay, cis trans isomerism da geometrical isomerism thila irukku. So I hope it's clear allada. Then we are moving to optical isomerism. So when you consider optical isomerism, so optical isomerism I will, so in a unpolarized light and a nicole prism pass பண்ணும்போது you will get polarized light. Okay, listen carefully, you will get polarized light. So அந்த polarized light என்ன solutionல ஒரு solutionல pass பண்ணும்போது you will get optically active. Okay, so maybe okay அந்த solution, okay அந்த solution na நம்மளோட compound. Okay, so நம்மளோட என்ன coordinate compound solution. Okay, so அந்த light, okay that plain polarized light ஓட direction maybe அந்த same directionல இருக்கலாம். Okay, இல்லனா right sideல rotate பண்ணலாம், இல்லனா left sideல rotate பண்ணலாம். Okay, so and the same direction, okay, and the same direction light pass பண்ணி வெளிய வந்தா we can say that this is, okay, this is and the same direction la vanda we can say that it is optically inactive. So either right side இல்லனா left side la rotation நடந்திருக்குனா we can say that it is optically active. It is optically active. This is also optically active. Optically active. It is also optically active. So guys, suppose on the light right side la rotate பண்ணிருக்குனா that is actually dextro-rotatory. Okay, that is actually dextro-rotatory. Okay, suppose when the light right side la left side la rotate பண்ணிருக்குனா that is actually levo-rotatory. Okay, so and or we can write L or we can write negative. Okay, in case of optical isomerism, optically active right side la rotate பண்ணிருக்குனா you can write D and positive. Okay, D and positive. I hope it's clear. So when you consider and adha first ஒரு method and next ஒரு molecule optical isomerism possess பண்ணுதுன்னு எப்படி identify பண்ணலாம்? Normally உங்களுக்கு தெரியும்ல mirror image, non superimposable mirror image ஆ இருக்கணும். Okay, ma'am, what is non superimposable mirror image? So here you can see a object. Okay, A M B. So அதோட mirror image எப்படி இருக்கும்டா? So that is B A. It's not what. This is wrong. இதோட mirror image actually BMA. Okay, இதோட mirror image என்னடா BMA. So இந்த AMB எடுத்து இதோட மேல வெச்சா, okay, இதோட just அதோட direct அது மேல வெச்சா, so என்ன கரெக்ட்டா? Okay, so when you consider this finger, okay, when you consider this finger ஒன்னும் வேண்டாம். So yes, this is the object and this is the image. Okay, so இந்த object mirror imageல என்ன டைரக்ட்டா பேஸ்ட் பண்ணிருக்குனா, okay, so உங்களுக்கு என்ன கிடைக்கும்? non superimposable தான் கிடைக்கும். Okay, non superimposable mirror image you will get. So I will show you. இதுதான் P. Okay, P ஓட mirror image என்ன? இப்படி வரும். Okay, so இத அந்த P எடுத்துட்டு இங்க வச்சா, so I will show you. இதோட P, this is P and அதோட mirror image is actually இப்படி வரும்ல. So this is actually non-superimposable. Okay, this is actually non-superimposable. If it is if a molecule is non-superimposable means we can say that if a molecule is non-superimposable means we can say that what we can say that it is optically active. It is optically active. I hope it's clear. It is optically active. So here also you can see that it is dextrorotatory and levorotatory. Okay, this is dextro and that is levorotatory. And yeah. Then we are moving to very important concept, that is valence bond theory. Okay, valence bond theory. So guys, I think you all are ready for valence bond theory. Guys, are you ready for valence bonds? ഒരു 7:15 ആകുമ്പോൾ ക്ലാസ് മുടിയും. ഓക്കെ, ബിക്കോസ് 7:30க்கு கோபிகா மேமோட another session is there. ஸோ அதோட முன்னாடி இந்த செஷன் முடியும். ஓகே, கோகு கிம்மையா வா கிம்மையா வா கிம்மையா தா. Guys, yeah. So that is valence bond theory. So what is valence bond theory? So it is the theory which describe chemical bonding. That is actually valence bond theory. Normally chemical bonding describe பண்ற ஒரு theory தான் valence bond theory. And VBT states that the overlap of incompletely filled atomic orbital. Okay. So here incompletely filled atomic orbitals leads to the formation of chemical bonds. So incompletely filled atomic orbitals combine பண்ணிட்டு தான் இல்லனா overlap பண்ணிட்டு தான் என்ன form ஆகுது, chemically bonded. Normally chemical bonds form ஆகுது between two atoms. So two atomsல chemical bond form ஆகுறதுக்கு reason என்னடா, so formation of or the incompletely filled atoms ஓட orbitals overlap பண்ணிட்டு தான். Okay, so the unpaired electrons are shared and hybrid orbital is formed. Okay, unpaired electrons are shared and hybrid orbitals are formed. So guys, இதுல important ஆன okay coordination number, type of hybridization, and here you can see distribution of hybrid orbital in space. Okay, so space la eppadi structure adoda structure and the space la eppadi irukku. Okay, okay, so adha. Okay, so here you can see coordination number is 4. If coordination number is 4 means so rendu chance da irukku. Okay, so adoda hybridization either sp3 agala illana dsp2 agala. Okay, sp3 illana dsp3 agala, sp2 agala. Okay, and adoda suppose sp3 na adoda hybridization spatial arrangement is actually tetrahedral. Okay, tetrahedral structure theriyumla. So tetrahedral illa dsp2 means adoda structure is actually square planar. Okay, square planar oru planar oru plane la 4 squares madiri irukum. This central atom inga, so it's look like square. Okay, square planar. Okay, next. So if coordination number is 5, adukku two options da irukku, sp3d or dsp3. Okay, so adukku ena trigonal bipyramidal da structure varum, and coordination number 6 vanda two options irukku hybridization la, maybe sp3d2 varala illana d2 sp3 varala, and it is octahedral, ரெண்டுமே octahedral தான். And coordination number 2 வந்தா either அதோட hybridization sp வரலாம், sp மட்டும் தான் வரும், and அதோட structure is actually linear-ஆ இருக்கலாம். Okay, yeah, I will watch anime. So yes, here we can do one question. Okay, explain hybridization geometry, magnetic moment. So in the madri edach, okay, maybe they will ask hybridization, or they will ask geometry, or they will ask in hybridization geometry, magnetic moment, magnetic character or spin of the following compound. Here you can see one compound NiH2O 6 times 2 plus. So in the molecule order hybridization illana magnetic character and write the hybridization geometry, magnetic character, magnetic momentum. Ellame just try to write. Yes, definitely ada inga irundhu question varadhukku chances irukku. Okay, indha madri oru molecule they will give you. Okay, definitely they will give you a molecule. So indha madri oru molecule tharu. So they will ask geometry, magnetic momentum or hybridization, magnetic character. Yadachu they will ask. Okay, so you can do. So try. This is a central metal. Okay, this is a central metal atom. So central metal atom vechittu just try. Come on. sp3d2. So here important another ligand. Okay, ligand. That ligand is actually two type of ligand irukku. Strong ligand irukku, weak ligand irukku. So yeah, we can start. So how we will start ada? How we will start? So we know that here water, when you consider water, water is a weak ligand or strong ligand. Tell me, water is a weak ligand or strong ligand? Is water is a weak ligand or strong ligand? Tell me quickly. Come on da. Water is a weak ligand or strong ligand? No answer. Water is a weak ligand. Okay, weak ligand. So what is the speciality of weak ligand and strong ligand? If we are using weak field ligand or weak ligand, so weak ligand use panna anga enna pairing nadakadu. Okay, when you consider weak ligand, okay, weak ligand is there means no pairing. Strong ligand la you can see pairing. You can see pairing of electron. Pairing of electrons. So we can start it up. Okay. Yeah. So nickel. What is the atomic number of nickel? Ada? What is the atomic number of nickel? What is the atomic number of nickel? What is the atomic number of nickel? Come on. 28. Yes. Ar 4s2 3d8. Okay. This is the electronic configuration of nickel. So here we know that it is actually, okay, this molecule is actually, here you can see it is +2. So we know that water, when you consider water, water is a neutral ligand. Okay, it's very important question. In the question in the madri question definite either they will ask hybridization, geometry or magnetic momentum, magnetic character, spin. Edachu oru question varudhukku chances irukku. Okay, so yes, it is actually +2. Okay, +2 da. So +2 nu solumbodhu we know that it is actually water. Okay, water. So water oda electronic water na enada, it's a neutral ligand. Okay, it's a neutral ligand. So neutral ligand oda oxidation number illana charge is actually 0. So we know that nickel is actually directly nickel oda charge da +2. So that means what is the meaning of +2? +2 means it's donated 2 electron. That means ipo nickel oda kaila evlo electrons are there? Nickel 2 plus, argon 4s0, 3d10. Okay, not 3d10, 3d8. So then you should write the write the electronic configuration. Electronic configuration in the sense you can write arrangement. Okay, electrons oda arrangement we can do. Okay, this is 4s. 4s la 0 electron da ipo irukku. Okay, 4s la 0 electron is there, and 3d 2 3 4 5 3d. So 3d la how many electrons are there? 8 electron. 1 2 3 4 5 6 7 8 electrons are there. So we are using actually weak electrolyte, that means weak ligand. Okay, weak electrolyte, not electrolyte, weak ligand. Okay, so here we are using weak ligand, so that means no pairing. Okay, there is no pairing. No pairing means appa enna nadakunda? So no pairing means here you can see this is actually 3D. Okay, so idukku appra yaru varum? So 3D ku appra yaru vandirukku? Again enna 3D ku appra you can see S. Oh you, I want to draw again. So you can see here 3D ku appra, can I draw here? I think it's visible allada. So I can draw here alle. So S is there, P is there, S is there, P is there, then I will draw the C. 1 2 3 4 5, yes, 8 electrons. 1 2 3 4 5 6 7 8. Okay, so idukku appra yaar irukkuda? So idukku appra you can see yes, 1 S P D. Okay, S la 1 2 3 4. So how many water molecules are there? 6 water molecule is there. Okay, 6 water molecule is there. This is S P D. Okay, so one water molecule will give 2 electron. Okay, one water molecule will give 2 electrons. So that means 6 water molecule will give 6 pair of electron. Okay, one water molecule will give 1 pair of electron. That means 6 water molecule will give 6 pair of electrons. So 1 2 3 4 5 6. Okay, inga enna first partially fill pannittu completely fill pannano appadi illa. So inga what is the hybridization? So now tell me the hybridization. Now tell me the hybridization. Tell me the hybridization. Tell me the hybridization. Kyukka, you can write hybridization. You can write hybridization. So I am going to write the hybridization here. So what will be the hybridization ada? It is hybridization is actually sp3, sp3, p la 3 irukku and d la 2 irukku, sp3 d2. Okay, so what is the geometry? sp3 d2, what is the geometry? We can check the geometry here. sp3 d2, yes, sp3 d2. So the geometry is actually octahedral. Okay, you can confirm. Okay, you can confirm, definite confirm pannala. Inga irundhu definite oru question varum. Okay, what is the geometry? Geometry is octahedral. So you can write octahedral. Octahedral. And what is magnetic momentum? So magnetic momentum calculate பண்றதுக்கு ஒரு equation இருக்கு. So do you know that equation? So nu is equal to n into n plus 2. Okay, n into n plus 2. What is n? N means number of unpaired electron. Number of unpaired electron. Number of unpaired electron. Number of unpaired electrons. Okay, number of unpaired electrons. Okay, next number of unpaired electron you can calculate using that. Evlo number of unpaired electrons are there? We know that 2 is the unpaired electron, 2 da irukku. So 2 vechi calculate panna podum. Next is magnetic character. So what is magnetic character? Is it paramagnetic or diamagnetic? So here you can see unpaired electron is there. So unpaired electron is there means it is actually paramagnetic. Okay, it is actually paramagnetic. And spin, what is the spin? What is the spin? Spin means here you can see here you can see unpaired electron is there, okay. Unpaired electron is there means we can say that the spin is high spin, okay, high spin, okay, outer spin, okay, high spin or outer spin. Normally high outer spin is சொல்ல முடியாதடா, we will say either high spin or low spin. If unpaired electron is there means we can say that it is high spin, okay, high spin. If unpaired electron is there not there means it is low spin, okay. I hope it's clear. High spin complex, yes, very good. So it is high spin. I hope it's clear, okay. Yeah. So yes, next is actually limitation of VBT crystal field theory. Crystal field theory is very important, so we can do crystal field theory. Yeah. So octahedral, when you consider octahedral and tetrahedral, so tetrahedral illana octahedral la, so D la da electron varum, okay, ligand enna D la da fill agum, okay, ligand varumbodhu, okay, so ligand varumbodhu what will happen, so in the D subshell illana D orbital split agum, okay, D orbital enna split agum, so octahedral la split agradhu Eg and T2G, okay, Eg is high energy and T2G is less energy. When you consider tetrahedral, tetrahedral la T2G ki high energy and Eg ki energy kammiya irukku, okay. I hope it's clear allada, clear alla, and that value is very important, okay. Energy different value is also very important. You can expect question from this topic also. So idu ivlo da irukku. And colored compounds, so we know that normally coordination compound will form colored compound because of DD transition, okay, because of DD transition it will follow, it will shows colored compounds, okay, it will show colored compounds. Why? Because of DD transition. Yeah, here you can see coordination compounds and colors, okay, colors and wavelength adoda coordination and the compounds oda colors and like complementary, it will show complementary colors also, okay, it will absorb a color like a wavelength of a color and it will show the complementary color of that wavelength, okay. Yes. Yeah, inga oru wheel irukku, so you can see. So yes, I hope it's clear. So idoda PPT I will upload, okay. So ungalku edachu doubt irukka, oxidation number is 2, central metal atom, yes, correct. Any doubt guys, any doubt? So 100 likes aicha. So 100 likes, smash the like button. Yeah guys, smash the like button, come on, quick. Okay, so you can, I think you can download this PPT, I mean this session note. So இப்பவே போய் and AIO download பண்ணிக்கோங்க, free crash course, okay, free crash course app இருக்கு. So free crash course இருக்கு and from there you will get 45 plus complete full length mock test free-ஆ கிடைக்கும். So இப்பவே போய் join பண்ணிக்கோங்க, because already lots of students join பண்ணியிருக்கு, அவங்க எல்லாருமே அந்த free mock test attend பண்றாரு and they can access pedagogy library everything, okay. So இப்பவே போய் join பண்ணிக்கோங்க. So I hope clear-ஆ இருக்கும்னு நினைக்கிறேன், doubt இல்லைன்னு நினைக்கிறேன். If you have any doubt you can ask, okay guys. Do you have any doubt? All clear ma'am, okay. So yes, smash the like button then. So I hope it's clear, then bye bye guys.